Hello guys, you're welcome to my channel. Today I'm going to take you through a topic in physics, projectile motion. As you can see on the board, what is projectile motion? A projectile motion is a parabolic or trajectory path traced out by a body under the influence of air resistance and acceleration due to gravity. I'll take it again so you can take it down. A projectile motion is a parabolic or trajectory path traced out by a body under the influence of air resistance and acceleration due to gravity. Now, when you say that a body is performing a projectile motion, there must be three characteristics about this body, at least two. So, when a body has a parabolic path, which defines the body to be a perfect projectile, and or the body what move under the influence of air resistance and acceleration due to gravity. Now, a body can move under the influence of air resistance and has an acceleration due to gravity, but there is no a parabolic path to be traced by the body. That doesn't mean the body is not a projectile body, but the body is a projectile body, but not a perfect one. Therefore, I will be discussing the dimensions of projectile. We have one-dimensional projectile and we have two-dimensional projectile. When you say one-dimensional projectile, it's a projectile that is related to one direction only. So the direction can either be vertical or horizontal. And when you said a projectile is two-dimensional, the projectile can be related to two directions, vertical and at the same time horizontal. So I'll take it one after the other. Let's talk about the one-dimensional projectile first. Now, when you talk about one-dimensional projectile, the body can be vertically upward. Fine. Let's see. This is the point of projection. That is the point at which you want to project a body. Just like I am here now. You can see this chalk on my hand now. If I project it from here, the point at which I project it is called the plane of projection. The plane of projection. So if this is the plane of projection, and I project a body upward, when this body is projected upward, the velocity is in vertical direction. And as the velocity moves upward, please note very well, as the velocity of this body moves upward, it reduces gradually. The velocity will be reducing until it gets to zero. When the velocity gets to zero, that point at which the velocity becomes zero is called the maximum height. The point at which what? The velocity becomes zero is called the maximum height. Now, immediately the velocity becomes zero at that point, which we refer to as maximum height, the body will start to fall down very fast than it was before. So the body will be moving faster and faster until it gets back to the point of projection. Now, you understand that at maximum height, it means the velocity has become what? Zero. So note that at maximum height, the velocity is zero. The point at which the velocity becomes zero is what we refer to as maximum height. Now, what can we deduce from this particular motion? I can deduce the time that takes the body to get to the maximum height. At the same time, I can also determine the maximum height reached by the body. And at the same time, I can determine the time that takes this body to be on air, which we refer to as time of flight. Now let's see. If I want to know the time that takes this body to get to the maximum height, I will say V equal U plus AT. If you want to know how we got this equation, I have a video on that and you're going to see that in the description box below. You can watch it and understand more about this. Now, as the body is projected upward, this acceleration is linear acceleration, but the acceleration process there is acceleration due to gravity, and it's going to be negative because it's moving against gravity, it's moving upward. At maximum height, which we are talking about, the final velocity becomes 0. So if we input these values into this equation, I'll be having 0 to equal u plus, this will become negative gt. So if I take this to the other side, I have gt to equal what? U. Hence, t is equals to u over g. Let's say this is equation 1. Now, we are now interested, we have known how to determine the time that will take the body to reach the maximum height. Now, we want to know the time that will take the body to be on air, which we refer to as time of flight. The time of flight, that is the time that will take this body to be on air, is going to be twice the time that takes it to get to the maximum height. It's just like you're talking about the time that takes the body to move to the maximum height and the time that takes the body to what? Come back to the point of projection. So t will become 2 of the small t. Hence, t is equals to 2u over g. This is equation 2, and this is called the time of flight. Now, this is the maximum height reached by the body. What determines the maximum height that the body will reach? You may be asked, and you need to know. What really determines the maximum height that the body will get to is the velocity that you use to launch the body initially. If you look at the chalk in my hand now, if I launch this chalk with a very small velocity, you see now that the height that the body covered before coming back to my palm is very short. But if I launch it to a very high velocity like this, you see I have to stretch towards to catch it because it's covered a very maximum height. So when the velocity is high, the height will also be what? High. So automatically, if we are to get the maximum height reached, the velocity used in launching the body initially is very, very important. And that's why you see that it is initial velocity that we are seeing here. Are we together? Okay, if yes, now let's calculate for the maximum what? Maximum height covered by this body. Hence, I can say if I have v squared equal u squared plus 2as, I decided to make use of this equation because it makes it easier for me to do. Now, if this should be the case, at maximum height, v is equals to 0, remember, and our a is negative because the body is moving upward, and our s is equal to what? H. Because the s in this place is talking about what? Linear distance covered. But this one is talking about what? Height. So that's why we say s is equals to what? H. If that should be the case, we have 0 to equal u squared minus 2gh. So if I take this one to the other side of the equation, I'll have 2gh to equal u squared. Hence, the maximum height covered by the body is u squared over 2g. And this will be our third equation. So you get this clear now. So the maximum height covered by the body when you project it upward is u squared over 2g. And the time taken to reach the maximum height is what? T. And the time taken for the body to be on air, which we call time of flight, is 2u over g. Are we together? Now, we have considered one direction now when the body is projected vertically. What if the body is now projected horizontally? Let's see. Okay. Now, when the body is projected horizontally, let's say this is the vertical component of the body, and here is the horizontal component. Now, if the body is projected vertically, we've seen the case. Now, the body is projected now horizontally. When the body is projected horizontally, it's going to have horizontal velocity, while its vertical velocity will become 0. Remember, when the body is projected vertically upward, the horizontal velocity becomes 0 as well. Hence, if I project the body vertically upward, I'll have the body to move like this. Remember, if I throw this chalk horizontally like this now, the body will start falling gradually before it falls down to the ground. So the same thing happens here. This body falls gradually back to the point of projection, but not to that exact point. So it covers a distance horizontally. This distance this body covered horizontally is what we call range of a projectile. The distance covered horizontally. Now, this is the maximum height reached by the body when you launch it horizontally. And the velocity of the body is only at the horizontal level. Okay, what will be the value of this maximum height reached? Let's quickly look at that. We have that S is ut plus half at squared. Let's make use of this equation to determine that. Remember, the maximum height is vertical. The velocity at the vertical component is equal to what, class? 0. Thank you. So it means that u is what? 0, because the velocity at the vertical component is 0. We only have the velocity at the horizontal component. Hence, our S remains what? H max. So if I slot this into this equation, I will have that H max is equals to 1 over 2 gt squared, because the body is projected horizontally, so this g is positive now. Okay, the fact that the body has an horizontal velocity and not vertical velocity does not make this to become negative or to become 0. So it is going to be what? Positive. Okay, so this will serve as our fourth equation, and this is for maximum height when the body is projected horizontally. Okay, class, let us now determine the time that takes the body to get to that point. Let's see. From here now, we can make t the subject of the formula, isn't it? So I can say t squared is 2h over g. You know, when you multiply both sides by 2, it's going to cancel these 2 here, and this one will become 2h. If you divide both sides by g, t squared will stand on its own. Hence, t is the square root of 2h over g, and this is equation 5. Okay, now let us now see what is the distance covered horizontally, that is the range of the projectile. Let's know. Okay, that is very simple to determine now. So we still recall that S is ut plus 1 over 2 at squared. Okay, if this should be the case, our S now will be the distance covered horizontally. So S is equal to what? R. And this velocity now is no longer a vertical velocity, because we are not considering horizontal distance now. So this velocity becomes the horizontal velocity. Hence, because the body is projected horizontally, A will become G and will become what? 0. So we have that R is ut. So as R equal ut, what is our t? Our t is the square root of 2h over what? G. Hence, R is equals to u root 2h over g. And this will be our fifth equation. Remember, this is fourth. Sorry, this should be our sixth equation, rather. Thank you. Sorry. So this is our sixth equation now. So we have that R is equals to u square root of 2h all over g. Okay, I believe majority of you might not have seen this before in the class. You're welcome to my channel where you learn everything. Okay, now let's proceed the class now. When we talk about what two-dimensional projectile now. So we've talked about the one-dimensional projectile, which we have discussed the vertical direction and the horizontal direction. So now let's talk about the two-dimensional projectile. When you say a projectile is two-dimensional, like I said earlier, it shows that that projectile can be related to two directions, vertical and horizontal simultaneously. Or in a nutshell, we can say it is a projectile at an angle of inclination. Now, let's quickly look into that for better understanding of what I'm saying. Now, let us consider this is vertical component and here is horizontal component. This is a body that is projected. Now here will be the plane of projection. Remember, this is an angle of inclination, theta. And here is the resultant velocity. Now, from here to this point here will be the range, that is the distance covered horizontally, and from here down to this point here will be the maximum height. Now, what will be the velocity along the horizontal component, and what will be the velocity along the vertical component? Now, let's quickly look at this diagram. I can just decide to take this curve away from the diagram, and I will have something like this. So if I have this is an angle of inclination, and this is the what? Resultant what? Velocity. How will I get its horizontal component and its vertical component? So this is what we call resolution of a vector. When you want to break a single vector into its component, you can check the description box below to see the video on this particular explanation of resolution of a vector. So here will become u cos of theta, and here will become u sine of theta. It means the velocity along the vertical component is u sine theta, and the velocity along the horizontal component is what? U cos of theta. So now let's quickly look at that. What will be the time taken to get to this point, maximum point? So we are talking about the vertical direction now. So our velocity u is going to be uy, which is the same thing as saying u sine of theta. Hence, we have that the time taken to reach the maximum height is u sub y all over what? G. So our u sub y is u sine of theta all over what? G. So let's call this one equation 7. Now, the time taken for the body to be on air before getting back to the point of projection, which we call time of flight, will become 2 of small t. So we have t equal what? 2 of small t. Hence, our t will become 2u sine of theta all over g. Let's call this equation 8. Okay, if this is equation 8, let's talk about the maximum height now. That is the maximum height reached by the body. So we know that our maximum height, h max, is equals to u sub y all over 2g. Hence, the square here. Hence, our h max is equals to u square sine square theta all over 2g. This is equation 9. So our maximum height now is now what? U square sine square theta over 2g for two-dimensional projectile or a motion on an inclined angle. Okay, let's now talk about the distance traveled horizontally. That is the range of the distance, the maximum distance covered horizontally. Whichever one. So let's see. We recall that our R is u sub of x times what? T. Remember, this is what? Horizontal direction. So the velocity will be horizontal. And our velocity horizontally, u sub of x is u cos of theta. So we have that R is equals to u cos theta times T, which is 2u sine theta over g. So 2u sine theta over g. Okay, if this should be the case, R is equals to 2u squared sine theta cos theta over g. And this is the range of a projectile. Okay, let me quickly say something here. Let's do something there mathematically in order to make this equation look more simple. I would like you to recall from compound angle that if I double angle formulae, if I have sine 2a, this is the same thing as saying 2 sine a cos a. So if you look at this equation, the equation 2u squared sine theta cos theta, I can rewrite it as u squared. Let me use another color. I can rewrite it as u squared 2 sine theta cos theta. So if 2u squared sine theta cos theta can be written as u squared 2 sine theta cos theta, if you look at this, it's very similar to 2 sine A cos A. If 2 sine A cos A is now equals to what? Sine 2A. Hence, 2 sine theta cos theta is the same thing as saying what? Sine 2 theta. Hence, the range of the projectile will now become u squared sine 2 theta all over g. And this will be our 10th equation. So, the question now is, when is the range of a projectile tends to be maximum? A very nice question that most examiners usually ask students to know if they really understand the topic projectile motion. The range of a projectile theta will be maximum when theta is 45 degrees. So you can start varying any value of theta for this. Keep u square and g, keep them constant. Then start varying values for theta. You will see that you only get what? You get the maximum answer for r only when theta is 45 degrees. So here comes the end of the lecture today. You can check around you and see a lot of examples of projectile in your surroundings. Like when they throw javelin is an example of projectile. When you kick what? A football is an example of projectile. When you also do what? A somersault, it's also an example of projectile. And when you fire a bullet horizontally, it's also an example of projectile in your day-to-day life. When you throw a football, it's also an example of a projectile. And when you play, what is this game that I visually play? I could not remember. So anything that you can have a curve to trace along its path, it's regarded as a projectile motion. Don't forget to subscribe to this channel and click on the notification bell. As I drop video, you get notified, and I'll be dropping questions on this projectile motion, especially those questions that majority of past questions in Nigeria here solve wrong. I will be dropping them very soon. So click on the notification bell so that you get notified. Thank you for listening.